Hi everyone, Thomas Chaton presenting today. There will be two hosts, me and Nairia. I'm a staff research engineer at lightning.ai. Nairia is a senior developer relation manager. So today we are going to go through a workshop. It's actually build tailor ML application with lightning.ai. So here's the agenda of the session today. It's going to be roughly 1 hour. The first section will be around why do you need Lightning AI in 20 minutes. So we will go through a gentle introduction of the platform and the frameworks, and also how it can actually be used to speed up your ML development. And secondly, we will have a more hands-on workshop from 0 to 1 with Lightning, around 40 minutes. The first part will be around accelerating your training with the Lightning trainer. And the second part will be build tailored ML application to go beyond training. So we'll be covering 2 apps. The first one is really an app to really get started with the Lightning app frameworks. It's called the Train and Demo app. The second one is more kind of build your own ML platform kind of thing. It's called the Training Studio app or Research Studio app. And it's really a full-fledged platform that can support multiple users. So why do you need Lightning? A gentle introduction. So first of all, the Lightning framework can be installed directly from pip. So you can do like pip install Lightning. It comes with 20 million downloads already. We have 750 plus contributors, 10,000 organization trust us to run the deep learning task on the framework. We have quite a large community, around like 5,000 people on Slacks, and the framework recently passed the 20,000 stars. So the Lightning framework is structured in 3 different ways, so like these 3 core blocks. So when you import Lightning as L, the first 3 abstractions are the Lightning trainer, the Lightning module, and the Lightning data module, also known as PyTorch Lightning. That's what you might be familiar with. But we also recently introduced this new framework, Lightning app, which if the PyTorch Lightning was kind of abstracting the training logic, Lightning app abstracts the infrastructure logic to build systems. So this framework comes with like 3 abstraction, Lightning apps, Lightning flow, and Lightning work. And then the last part is the cloud compute, which really is associated with the Lightning AI platform to run the apps in the cloud. So apps can be run locally and in the cloud and have the same behavior. And that's something which I will cover a bit later. Lightning also has a pretty large ecosystem of libraries. So you have Lightning Flash, which is an easy way to get started. It's a PyTorch AI factory with thousands of models across 7 data modalities and 15 tasks. So modalities can be like images, point clouds, videos, text, and the tasks can be like classification, segmentation, translation, and so on. Torch metric, so those are 80 plus PyTorch metrics with built-in distributed support, which can be used in a completely standalone. So you don't need Lightning to use Torch metric. You can use it directly with your PyTorch code base and PyTorch projects. Then we have Lightning transformers. It's a library, a Lightning library built in to support transformers, and its goal was really to remove the boilerplate around using transformers and really like teach folks how to organize a code into Lightning module, Lightning data modules. So if you don't know about it, check it out. It's definitely quite interesting. And finally, the last one, which is coming soon, is Lightning Lite. So Lightning Lite exposes PyTorch Lightning famous accelerators and distributed strategies without the trainer. So you have full control, and you can switch between those different strategies to distribute your code without boilerplate. So check this out too. So I'm going to cover a bit more the Lightning AI platform. So to access the platform, you can simply, and I think I do have it somewhere opened already, so we can check this out. So to access the platform, you simply do lightning.ai, just like that, and you arrive on this page, which is the platform. So you can see here, it's really a platform to start from models and to build full stack AI application lightning fast, always by removing the boilerplate and enabling to scale and reduce your cost along the way, right? So it's really built for everyone, from researchers to ML startup and enterprise. Here you can switch between those personas, so the website will tell you what you can actually use. And here is actually an app, for example, we call it Muse, which use stable diffusion under the hood to perform predictions. So this app is directly embedded, but I will cover that also slightly more. Okay, so now I'm going to ask all of you to actually create your account. So you can go on lightning.ai if you haven't done it already. You can log in, so I'm going to go through all the steps. I'm going to sign off. So you can click here on login or join, right? So if you haven't, you just click here, you select, let's say, Google or GitHub, you select your account. When you have done that, you will be offered free credits, which is a monthly thing that you will get once you have an account. So one credit is $10, so you get 30 credits to run your apps and really start developing in the cloud if you want to test those things out. But note that every app also works locally, so the cloud is not a requirement. It's really meant if you want to share those apps with people you know. Okay, so does anyone have any issue? Maybe I can check the comments. So does anyone have an issue creating the account? So TechGamer, is it free? So you get free credits, $30 to start building apps. So in that regard, it is free to start, and the entire workshop will be free. Cool. Okay, I can see a couple of extra questions. And some people have answered. That's great. What are competitors of Lightning? What are the advantage of to use the framework? Yeah, so that's something which I will cover, but I don't think there is really a competitor in the sense that the framework comes with like very novel way of building systems, and by the end of the workshop you will see how different it is from everything which exists, and give you incentive to use it for your own applications. Okay, so let's keep going with the slide. So I hope everyone has created the accounts and got the free credit, so we can keep going with everything, right? So why do you need Lightning AI? It's really meant to speed up your ML development, right? So what can you build with Lightning AI? So you can build model training at scale, and I will cover some of that, model deployment, MLOps platform, scalable research demos. So what you can do, for example, is go on the app gallery, find an app to run, and open the GitHub repo in another tab, right? So here we are going to go on the app gallery, and you can take the same step as I do, right? And we are going to go for this app, which is considered as an AI product. So it's a full-fledged app with like a React UI and so on. It's called Muse, and it relies on stable diffusion, right? So here you can, when you get prompted on this page, you can see two buttons, trade for free and clone and run. If you click trade for free, you will actually be able to try the app. So this app is using the Lightning App framework and a React UI. So you can enter any prompt you want, and when you click Muse, this will make a request to the servers, and you will get your prediction. So one thing which is very interesting here, and we can really very briefly look at the code base. So the code is open source, right? You can simply click here on GitHub repo and access the code base. One thing which is very interesting about this app in particular is it implements a load balancer 100% in Python, right? So the more requests and users you get on this app, the more GPUs will be allocated, and the entire infrastructure will be scalable, and all of that completely controlled from Python. I can quickly show some of that, and I'm advising people to have a look at the code. I think it's a very interesting thing. So here we have, for example, a load balancer, and the load balancer is going to dynamically create, like, handle the request, and then we will have a mechanism to auto-scale the number of servers, right? So here we see auto-scale, and here we see that we are dynamically creating servers when the load increases. I will let people actually have a look more in depth. but you are free to use the app and see by yourself. Okay, so let's keep going. You can also like click here, clone and run. So if you do that, that's going to make a clone of this app on your own account. And here you will see that the machine is, the app is first going to be provisioned, then the code is going to be downloaded, the dependencies are going to be installed. And when the app is ready, the open button here will be visible. You click on it and you will get a fork or a clone of this app running on your own account. Okay, I see a couple of questions. Yeah, so one quick information here. Yes, so the Muse app can support like 3,000 concurrent users, and I think to do that you get like, I don't know, dozens of GPUs kind of auto-scale directly from Python to support the loads when users comes around. Okay, so let's go with the slides. So one thing which is really interesting about Lightning apps is it's really meant also to put everything which truly matters for you in a single place, right? So one thing which we worked on was to ensure that you can embed multiple systems into a single place, right? So if you go on the app gallery and then go within the Jumpstart project with these templates, you can find the research poster, and the research poster is currently live, so you can actually try it out. I'm going to zoom in. Some people say it's a bit too small. Okay, so try it for free. Right, so here you have an app which has 6 tabs, everything related to the OpenAPI, to the clip paper from OpenAI, right? So the person who develops that app said, okay, I want to have everything related to this app in a single place. I'm going to embed in the first tab the blog post from OpenAI on clip. In the second tab, I will actually embed the PDF paper about clip. All right, so here just charge, and now you can have access to the entire paper. In the third tab, I want to embed a markdown, which really sum up like all the key contribution of the clip research. In the fourth one, there's actually a notebook with all the steps to actually kind of evaluate the model. In the fifth one, you have actually the weight and biases logs for reproducing some of the training of the model, right? So here you can see the training curves. You can see, for example, the generated image and so on. The retrieve image, sorry. And then in the last tab, you have Gradio UI, so you can actually try it out. And if you enter, let's say, a sentence, it's going to retrieve the images which are close to that. So here you can see, for example, we put going into space, and we found a couple of images matching this input. But I could also try with cat reading a book, and the same thing will actually happen, right? So all of that actually happen into a single app. And if you check the repo, which again is fully open source, if you check the app, the way to support that was simply to override the configure layout hook and to provide a list of dictionaries where the name was the name of the tabs, and the content was as a URL or a work or a flow, and that's something which I will cover a bit further. But here you see how simple it is already to start organizing all the service into a single place. Okay, I'm going to close that. Cool. Okay, so here's another app which is the Omniverse app, right? So it has a React UI. It supports dynamic parallel GPU training. And one thing which is very important here with those kind of apps is you can dynamically create and delete resources in the cloud, right? So you're not, like if you were to use a DAG, for example, you're very fixed with the kind of structure you create. Here you have a system which not only has a distributed state, which means that every component knows what other components are doing, and all of that orchestrated from the flow. But also you can dynamically create resources. So for example, in this app, which was built in collaboration with NVIDIA, you can, for example, generate random data, right? So you can import some data. The way the data are uploaded right now is we are running a Flask server with which acts as a file server, so we can upload some data. then you can, let's say, like generate some scenes, right? So that's going to create another resources with GPU enables to create the scenes where 3D objects are going to be placed in those scenes. So here, if I want to be too fast, we selected a warehouse, and we also selected this object, and the generator, the Omniverse generator, simply put that vehicle within the scenes. What's really interesting now is this is a way to generate synthetic data to actually train object detection models to find those kind of vehicles within warehouses, right? So once you have, like, let's say, a good data set which has been generated, then now you can actually train some models. So here we launched grid search to train an efficient depth model to locate all those different machines, all those different vehicles within the scenes, right? So here, the models have been trained, and what you can see is as everything, as all the state is distributed, right? So here you have to think that dynamically we are creating like 5 machines. Okay, sorry, somehow I went to the next slides. So dynamically you get like 5 machines being started. And here you can see that in real time at the top, you get the progress. So the way it works is like one machine is going to modify its progress state. And as it is being broadcasted to the floor and then to the UI, you can see that live on the UI, right? So dynamically, you can track the progress of your machines, and you can really coordinate them in the way you want. Okay, so let's go to the next slides. Okay, up. Okay, and one thing which is really interesting too is all those app galleries on the platform are actually templates that you can use as an inspiration, or actually a template you can use to just get started with the things that matters to you, right? So it really comes as templates for everything, and a lot of tools, I would say actually most tools can be embedded within an app. So here you have examples of different apps which has been created. Here you can see like TensorBoard, for example. Here you can see like Prometheus, and you can see Prometheus here in the back. You can see a notebook was embedded within the app. You can see weight and biases. You can see Locus to do load balancing and load testing on APIs. Label Studio and 51 can be embedded to do image annotation or annotating data in general. Here you can see Gradio. Here you can see Streamlight again, and here you can see Panel, for example. Right. So all of those come as templates. You can just like use to like really get you started and building the systems that fits your needs. So where can you actually run Lightning apps? So you can run them on-prem, so you can run them on your own machine, and you can also run them on your own clusters. So that's very flexible, right? In that sense, you can just make sure that works locally as you wish. And then if you want to scale out, you can run it on the public cloud, on Lightning Cloud. But another option is if you have your own AWS, let's say, account, you could do what we call like bring your own cluster, BYOC. So that will spin up, just by using a click on the UI, that will spin up the cluster on your account, and then you could run those app directly there. So all your data, everything is fully secure and private. So I'm going to go directly on the workshop now. Let me quickly check if I get any questions. No, I don't think I've seen any questions. Okay, cool. So I'm going to go through all the steps. Feel free to do it alongside me. If you have any questions, please do ask on the chat. I will be monitoring. Okay, cool. So the first step is, so I'm just going to go through the steps before doing them. So I'm going to create a Lightning folder. I'm going to create a virtual environment. I'm going to clone and install Lightning from master. And I'm going to clone 2 extra projects, Lightning Quick Start, Lightning HPO, and just install all those requirements. So that takes quite a lot of time. So we are going to go and do all of that, right? So normally we should get going through all those things in just a couple of minutes, hopefully. So first step, you create the Okay, so one question, can you do an example of pose estimation app on the cloud with AutoScale? So we are going to start abstracting all those components, right? So one thing which is very interesting with apps is you can actually create reusable components. One of those will be the load balancer. And then if you have a pose estimation case and you want to actually expose that, and maybe even like create a product and start having clients, you could reuse those components for your use case. Okay, so I've created my work here. I'm going to go inside. The next step is to create a virtual environment, right? So I'm using Pioneer, but feel free to use everything else. I'm using 3.8.5. You can use version above 3.8, but I would advise to use the same one. So there's less chance of errors. So I'm creating my virtual environment. At the same time, I'm going to go on GitHub, right? So you can put Lightning GitHub. And the second link is the one you want, right? So we are going to install from source. The reason being, yes, will the GitHub link be shared? I don't know if I can share that. No, okay, it doesn't seem like I can share. But you can simply like put Lightning on Lightning GitHub on Google, and you will just find the links. Okay, so I'm going to clone this first repo. We are not using PyPy right now. We just face some issues today. So we are just going to do it from source, and normally everything should be fine. Okay, so while this one installed, the next one to install is Lightning Quick Start. So you can simply add Quick Start on the link here, and same thing. We are going to clone this one. Takes a little bit of time. I'm going to do it in a separate process. Okay, and I'm going to download the third one. By the same occasion, when you go on those repos, don't hesitate to give a star. That's always very, very helpful. Okay, cool. So the first one is installed. So I'm going to source my virtual environment, and I'm going to go in the Lightning and just install it. Right. So that's going to take a little bit of time, and then you will have Lightning on your machine. Then we will install Lightning Quick Start, and we will install Lightning HPO. You can do all those steps also on your machine. If you face any issues, please just add some comments on the URL. Okay, any issues so far? No, okay, I don't see any issues. Okay, cool. So let's keep going with the slides as this goes. So the first part is going to be around training, right? Training with the Lightning Trainer. So the first thing we are going to do is in Lightning Quick Start, there is a train.py file we are going to use, which enables to train a simple CNN on the MIS datasets. And we are going to just to run it. So I'm going to introduce folks to PyTorch Lightning, for people who have actually never seen it, right? So if you get in Lightning Quick Start, I can simply open the repo. Right, so I'm going to open the repo, just one sec. I'm going to change it right here, and now everyone should see it. Okay, so I'm going to create it, and here you have the training script. So I'm going to cover it through the slides first, and then we will go back, right? So the first component to know about for people who are not familiar with PyTorch Lightning is the Lightning module. So the Lightning module is really a way to organize and standardize your PyTorch code. So all your model code, all your research actually go within this component. There are a couple of benefits, but the main ones are really readability. Wherever you go, if you go on a PyTorch Lightning code base, you know that the first thing you do is search for the Lightning module and look at the training step, validation step, init method to really find the things that matters to you, right? So in the init method, you instantiate your module, maybe your metrics. You can also save all your parameters. Then you need to implement the training step. So the training step takes a batch ID, and compute the loss. You can also log to the selected loggers by simply doing cell.log, providing the name of the metric, providing the value and how you want that to be reduced. So on step, on epoch, or so Finally, the validation step. So here you see that you don't need to return the loss. It's really for validation. So you forward, you compute your metrics, and you can just log them. And finally, the last important hook is config optimizers, where you simply define your optimizers and just return them. Right. So the second block is, so the second important component is the lightning data module, which really organizes your data loader. So you have a couple of hooks you need to override, but the main ones are train, val, test, and predict data loader. And it's really meant to improve interoperability. So if you want to change your data, it's very straightforward. It's very easy to convert also from pure PyTorch, right? So here I have my train data loader, I have my val data loader, and now I can use it directly with the trainer or with the Lightning CLI. So here I'm actually using the Lightning CLI, which comes with PyTorch Lightning. One great thing about it is you can simply provide your classes, and then it removes all the boilerplate around configuration. So some people like use tools like Hydra or so on. One good thing here is you don't even need those tools when you use the Lightning CLI. It simply is just infill all the metadata to instantiate those classes and get you going as needed. So I'm going to go to the Tron and demo app. So actually, before we jump here, let's just quickly look at the code base, which was here, right? So again, just for quickly cover everything we've seen. Okay, so here we can see that I had my NN modules, which is a simple CNN. I have my image classifier where I define my model. I have my training step, my validation step. I have my means data modules, and I have my CLI. So now if I do train.script, I should actually be able to train the model very quickly. Normally, if I don't provide any arguments, like the model is just going to train for an infinite number of epochs. Otherwise, you can simply add, let's say, dash train max epoch equal 1, and that will train for a single epoch. So the first time you create a virtual environment, it takes a little bit of time to set up. So it's kind of, okay, I didn't install the requirements here. So let's do that. I'm missing, I think, I was missing Torch Vision. Okay, so you can do that also on your side. Once you have installed Lightning, you can install Lightning Quick Start, and then we'll go to Lightning HPM. Yeah, it's definitely possible to send those slides for people who wants to try all those things by themselves in later on. Okay, so while this thing is installing, I will go back to the app. I'm just going to quickly jump back to the slides. Okay, so what are Lightning apps, right? So Lightning apps are a lot of things. They are class agnostic. They are fault tolerant. They are fully distributed, but the thing which is really nice is the distribution is optional. So you don't necessarily have to go into distributed system, but that's something which comes handy when you want to really like do, let's say, like scale training or scale serving. It's production ready. You can debug it locally and then run it in the cloud. It's highly interactive and interactive. So I was saying that we have this global state between all the components continuously being synced by the framework. So as a user, you kind of change a variable somewhere, and then it's being reflected directly on the UI. Connect multiple UI. So I've seen with the research app, you can simply add multiple tabs of different types in a single place and jump between those. It's built for team collaboration, so the apps propose and provide a CLI system, which I will cover a bit more in details, but multiple people can actually access an app and just collaborate in a single place. It's framework agnostic, so it works very well with PyTorch Lightning. We have components specifically designed for PyTorch Lightning, so you can do like multi-node training and so on, but you don't actually have to use them. And if you were, let's say, a Keras user, scikit-learn user, if even you didn't want to use Python, that's something you could actually do. You get all those jumpstart ML templates. Components and ecosystem, it's stateful and checkpointable. Distributed storage, so we have this ability of moving files in a very straightforward way between components if needed, and our plan is to move toward a fully serverless application. So do you need to react to them? Do you need to react to use them properly? I'm not fully sure what you mean, Eduardo. Are you specifically talking about the state of the app? Could you add more details while about your question? Okay, I'm going to quickly check that. Normally I should be, yeah, okay, the installation is taking more than expected. Yeah, okay, so let's keep going through the slide as the installation goes through. So the Lightning App framework is really just code, right? It builds a Lightning way, and we provide 3 new abstraction: the app, the flow, and the work. So I'm going to jump this one. I think there was some issues later on today when I tried, so I'm going to jump this one. So to actually run an app, you can like create Lightning work components. So here I'm creating 2 components, a partitioning script and the image shape radio. So the first one is actually going to run a training script, and the second one is going to serve the model once it's been trained. So what you will do once you have those 2 components is you want them to be orchestrated, right? And that's really where the states comes in. So here you could simply, and that's really illustrative, what I'm showing here. The orchestration is actually done by the flow. So here you see that first I'm going to run, so the way the flow runs, it runs within an infinite loop, right? And what you will actually effectively do is you will do like train work.run. So you're going to start the train component in the class that will create a machine. And then you can simply like check the state, right? So did the work actually finished? And if it did finish, you can provide the train work base model path, which is a reference to, let's say, the checkpoint, which was generated by the training, and pass it to the server. When you do that, not only the server work is going to start a new machine to actually serve Gradio, but also it's going to transfer the checkpoint from the train machine to the work machine. So the way to actually make this work is to organize that within what we call a flow. So the flow is really this thing which orchestrates, right? It's not meant to do any heavy lifting. All the heavy work is done by the Lightning work objects. But the execution is done here, right? So the way you will do it is you will create a Lightning flow. You will create the components you need. So a flow can have flows as children's, but you can also have works. Works are really like the leaves of the tree of components defined there. So here you can see that I'm creating like those 2 components, the partitioning script and the image of radio, and then I can simply run them. I will first start the training. When it has succeeded, I will serve it. Right, and then the final step is you get your flow and simply pass it to the Lightning apps, and now you can run that equally locally and in the cloud. If you want to run it locally, you do Lightning run app.py. If you want to run it in the cloud, you do Lightning run app.py -- cloud, and that will simply take it to the cloud. So a couple of questions. Can Lightning be used with GPU and TPU with the same code? So why now in the cloud we don't support TPUs, only GPUs? So yes, you can use GPUs, but you can also run, I think, Lightning apps within Collapse. I tried recently with the Quick Start app. So in theory, you could just run your apps there. It won't be distributed. It will just run locally, but within Collapse. So if you have worked intensively with TensorFlow, you could simply just run the app with it and try it. Yeah, and feel free to try PyTorch Lightning. I think he helps a lot removing boilerplate. So I think it's a good thing to try, and if you feel comfortable with the switch, then join our Slack and get more information about how to get forward. Okay, so everything has been installed. I'm going to run the script, right? So here I'm going to actually train simple CNN on Minst. So normally all my dependencies should be installed. Normally it should just go through. The first time we run it again, first time we run Python within a new virtual environment, it takes a bit of time. So let's just wait a bit. Okay, so here I can see the data got downloaded, and now I can see my training starts, and I can see the loss is going down, right? So quite straightforward. And I was saying that the Lightning CLI enables to do a lot of things, right? So you can modify, actually, if I put -L, you will see that every argument to the classes, to the trainer, are automatically inferred. So you can modify all of those things directly from the CLI, right? So if you wanted to, let's say, modify the logger and use weight and biases, if you wanted to change anything, you can just do it from the CLI without having to manage this mess of YAML files, right? So here I'm going to say trainer max epochs, and I'm going just to train for, let's say, 2 epochs, right? And I'm going to also say trainer dot limit train batches, and I'm going to limit the train data loader to 5 batches, and I'm going to do the same for actually I have a tiny typo here. Right, so here it's going to do 2 epochs of 10 batch each, so it should be very fast. And I think here we actually okay, so here we have some outdated code, it seems. Interesting. Do I have... Why did you break? Okay, so here's an interesting... We made a release, and this example actually broke in the process. So one of the hook unsafe checkpoint, I'm actually not overriding this hook, so it's quite surprising that he actually breaks. Okay, so that's something I will look into later on. But yeah, normally the training should just go forward, and everything should just work as expected. Okay, cool. So let's keep going. Okay, so the next thing we can do is actually run the app, and normally it should work out unless this break entirely the app. So let's see. So what you can do to run the app is to do lightning run app app.py. Okay, some installation issues. Yeah, so that's something which broke today and which we try to resolve. Again, sometimes things doesn't work the way we want, so let's just see if I can get this to work. Okay, so here what we are expecting the app to do is to train a model when the model has trained, so when there's actually a best model path, start another machine which contains this best model path, right? So which will start Gradio. And in my tabs, in my UI, I want 2 tabs. I want the model training a model training tab, which is going to show me the train work. And I want also an interactive demo, which is going to show me the server work, right? So here, if I go there, now I should see a TensorBoard, which shows that the model has been trained, right? And then in the second UI, I should actually see that Gradio started with a model which just got trained, right? And now if I select an image and make a prediction, I can see that the model is properly predicting those things. So here, if I put, let's say, a 5, I can see I'm getting a 5. So here you can see in a single app, in only 28 lines of code, you are able to train and serve with like demo a model, and this will work in the cloud in a fully distributed way, and also to embed the things which matters to you, so TensorBoard and Gradio in a single place. So if you're doing research, for example, and you want to share your work with anyone, you can simply run this app, for example, in the cloud, and share that link with anyone else, and now they can see your training logs, and they can also try your models live, right? So it's a single app which really demonstrates how to provide reproducible systems for people to go through your research. Okay, cool. So I hope everyone was able to reproduce that. I'm going to, you can also run this app in the cloud. So you provide / cloud. And I think we have bug in the cloud. So we need to install it with package lightning for one here. It's a temporary hack for the issue we faced today. So let's see. So the way it will work right now is the files are going to be packaged and uploaded to the cloud. So the app is actually going to run, and the exact same behaviors should appear in the cloud. So if you have created your account and got your free credits, you can do the same as me, but / cloud, and now the app is going to start in the cloud. And you're going to see same as me. Quick start is starting. First, we provision the machine, we download the code, install the dependencies, starting the app, and hopefully everything should go through. Okay, I'm going to go forward with the slides. Okay, cool. So once you have run the app, you can, as we were saying, you can really like configure the layout as you wish. And here's the API to do it with the framework. Here I'm creating two tabs, a model training and interactive demos, in which I'm simply providing the works. The works have a URL locally and in the cloud, so we can simply embed them as iframes, right? So the first tab will generate this part of the UI, and the second tab will generate this one. Cool. Okay, so the second part is going to be more focused on building a tailored ML application, which really goes beyond training. So it's really about building your own ML platform, right? I think we all face this issue where you get into a platform and then it does like 80% of what you want, but what you really care about is the 20% left. And usually you are kind of blocked with those vendors where not only is there a black box, but also if you request features, this might never go through, and your needs are not necessarily addressed. I think one thing which is really good here is the entire system is yours, which means everything is built in Python, and your entire infrastructure is coordinated this way, right? So I think Lightning apps in ways can be seen as I think for people who might have like background or platform knowledge, I would think as Lightning app as either one of the simplest Kubernetes clients, but also as a distributed React, right? So it really reacts on the state changes, and it will enable you to coordinate your machines this way. So the app I'm going to show here is kind of a custom ML platform, which is really related to training. What was the command to make the... Yeah, so the command is exactly the same. The only thing you need to do is add -- cloud. Gustav, right? So you lightning run app.py that runs the app locally on your machine, on your GPUs if you have some. Lightning run app.py -- cloud takes that app. If you are logged in, we'll ask you to. If you are not logged in, it will ask you to log in, and then the app starts in the cloud, right? So actually, I think if there were no bugs, yeah. So that's what I was afraid about. Like today, we faced a bug we need to resolve. So some of those apps might actually fail, but it should be resolved by tomorrow. Okay, let's keep going. Okay, so the second app I was going to show is the Research Studio, right? So we cloned that app, I think at the beginning, right? So let's just go right here. So it was actually this app, Lightning HPO, right? So you can simply like clone this repo and just get your things going. I'm just going to install it also, because that's going to take a little bit of time. Lightning HPO is really interesting for a lot of ways, or like this research studio app is really interesting for a lot of ways, because it provides a way for people to submit to submit their own training script and to run script in the cloud, right? So I'm actually going to show how the app looks when it runs for the first time. Right? So I'm going to do lightning run app.py. Yeah, okay, I get the same issue as I got, so I need to really resolve that. Okay, cool. So when you run the app, what you see here is this first tab, right? So you can see you have those two tabs. The first one is really where you run your hyperparameters and where you will see all your experiments. Second one is in the cloud. We support downloading and mounting data. So if you have like some private S3 buckets and you just want to mount this data to your works, you can do it, right? So the first thing we are going to do, right? So I'm going to create a second terminal. We are going to connect to the app. So the connecting to the app means we are going to download its CLI, right? So this app, actually, if we check it out, right? So if I check the app and check, for example, docs, I will see that this app provides here a couple of comments, which enables me to interact with the app through this REST API, right? So let's go back on the app. So here, the first thing we will be doing is I will connect to the app. So the app can run locally or in the cloud. If it runs locally, it's localhost, right? So I'm going to do the following. So when I do that, what happens is we are going to connect to the app and download the entire CLI. All right, so here you can see that now, if I do lightning-help, what I see is actually the Lightning app comments. All right, so now I can see there's a comment to create data. I have a comment to, let's say, start an experiment, to show some artifacts, and so on and so on, right? If I disconnect, right, so if I do, and here you can also disconnect from the app, right? So if I disconnect from the app now, let's just wait for 1 sec. Now I'm disconnected. If I go back on the app, I will get the global CLI of Lightning, right? So I'm going to connect again. We downloaded all the comments again, right? So what I'm going to do right now is I'm actually going to submit a sweep where I'm going to change the learning rate and the batch size for my scripts, right? So if I go in example scripts, right, I have this train.py file, which is exactly the same training script that we had right here, right? It's actually exactly the same. And our data module, so here we're exposing, let's say, a batch size, which I want to vary, but I can also modify, let's say, the learning rate of my model, right, of the optimizer. So here on the UI, I can copy this comment, right? So if I do actually lightning run sweep and put --help, I will see that I can launch a sweep. How interesting. How does it break? Let's see, does it work? Okay, there were a bug on the app. I will resolve that a bit later. Okay, so here what I did is I submitted a sweep for the train.py file, and I say, please create a grid search around those parameters. So the model LR and the batch the batch size for the data loader. And now we can see that on the UI, I have all those experiments which started, and actually let's just do one thing, right? So let's run slightly less at the same time. I'm just going to restart the app from scratch. So the app has a database in which we store all the metadata. So the app is actually fault tolerant and persistent. Right? So I'm just going to restart the app. Up, it just restarts from scratch. I don't have the previous run. It's all good. So I'm actually going to run instead an experiment. Normally that should just work as expected. All right, so here what happened is he connected to the app, he uploaded the code, and now we can see that in the cloud, so here locally, the Lightning app received that experiment, and it's actually training it right now. And here you can see in real time, we're actually collecting the progress of the model. So here we can see that 70% of the training has been done. When we get to 100%, we will get the score and so on. I can also open, let's say, the logger. And here I can see I get TensorBoard logger to actually visualize the training. All right, so I can see the model convergence on, which is kind of expected. Okay, so to run this app in the cloud, we have to do a very similar system, right? So I'm going to do package lightning equal 1. So the package lightning is not required. It's related to the bug we have. Normally that should work out. So let's try it out. And I'm going to go back to the slides. Yeah, so what we have seen here is that specific app provide a way for people to submit sweeps, so they can simply connect to the app, have access to this CLI, and really launch sweep and experiment directly in the cloud. So if you go again on lightning.po, on the lightning.po repo, I'm going to zoom in a little bit. So the first step was really, which we covered, is really run the app locally, right? So you install the app and just run it. Then you connect to the app, you get access to its CLI, and then you can simply launch, let's say, a sweep locally with the thing which to train the model. But one thing which is really interesting is this app in particular supports multi-node training. So if you launch the app in the cloud and connect to it, here we have a script which create a 1.6 billion large language GPT-2 transformer model. And we are using the library Lightning Transformers, Deep Speed, and Hugging Face to actually train that very large GPT model on the Wikitext dataset. And we are using Deep Speed stage 3, which is going to shard the model to actually train these very large models. So if you run this command, once you are connected to the app on this big model.py file, you will actually start training these very large models on 2 nodes with 4 V100 GPUs. And I'm going to while this, okay, so the app also fails in the cloud. Yeah, so I think, yeah, what happened today kind of broke a couple of things. I'm really sorry for that. But I can still explain how this works, right? So so let's quickly check Lightning. So I don't know if some of you are familiar with multi-node training. Maybe in the comments, anyone familiar with multi-node training? Okay, so I'm just going to quickly explain how we do multi-node training with Lightning apps, right? So I think when you see that, that will give you an idea of how powerful the framework can actually be, right? Because it's really about orchestrating systems. So at a high level, the Lightning framework provides this Lightning training component. And what you need to do with this component, so the API we created, is you simply provide the script you want to launch. So here it's your Python shining script, but it could also be a TensorFlow script, for example, for what we know. You say, I want 2 nodes, and I want to use this specific cloud compute. So here we are specifying a GPU fast multi, which is a machine with 4v100, right? When you do that, under the hood, this component is going to orchestrate those nodes. So the part which is interesting is just those lines of code, right? So those lines of code entirely orchestrate multi-node training, right? So I don't know if any of you have ever tried to do multi-node training in the cloud by yourself or so on, but it's a very hard problem. It's usually several languages working together to actually achieve that. Here you can simply do it just like 20 lines of code, right? So I'm going to quickly go over it and kind of explain how it works. So I have this work object, right? So a work object can be mentally associated to a machine. And I'm going to say, if I'm not initialized, simply go through the number of nodes and dynamically create a machine. All right, so here I'm going to create as many kind of objects, Python objects, as I have nodes. So here I put num nodes equal to, I'm actually going to create 2 Python objects, and I'm going to say I'm initialized. So here, for example, and as initialized is num nodes or script tags, all of those are part of the state of the objects, right? And then I'm going to say for all the works within this list of works, if they have an internal IP address, right? So the Python objects support networking, so they can communicate with each other, right? So when you start a Python object, when you start a work, it doesn't have this internal IP address before it's actually started, right? So this condition is going to be false the first time it runs. So we are going to call work.run, and work.run is going to dynamically start a machine in the cloud. And here I'm not providing any argument. So let's quickly look at the work.run method. So here what we are expecting is to get a list of internal URLs. And if none of those URLs are provided, I'm going to exit early, right? So what happens is that's really equivalent to doing start, right? So I'm starting all those machines, but I'm not running any code yet. I'm waiting for all of them to be ready at the same time. When they get ready, right, so when the run method executes the first tab without really triggering, the internal IP address gets populated. So what we can do now is, if that condition becomes true, which means like all the GPUs are actually available in the cloud, I can simply collect all of them, right? And here, remember, those are it's actually a distributed system. So this internal IP is part of the state of the work and was communicated from the work machine to the flow machine. Here I'm simply collecting all those IP addresses and ports and starting all the works with those things. So when you do distributed training, and in particular multi-node training, the only thing you really need is for all the machines to know the IP address of the first of what we call nodes, the node 0, right? So you could be training on 128 nodes, but the only thing which really matters is the master address of the first node, and for all the nodes to be aware of that. So here, once we get internal URLs, we simply extract the first API address and we extract the port, the number of runs. We set up a couple of extra PyTorch environment variables, and we just execute, right? And here what happens is we have completely set up on all those machines the environment variables for PyTorch to just start doing distributed training. So those two components like do a little bit more. So for example, they also like automatically checkpoint the best model and so on. But I think it's a very cool example on how flexible it is to just orchestrate things directly from Python, right? So those Python objects are actually machine in the cloud, and those machines have a state, and when those states get changes, you can receive them in your flow and coordinate your entire system this way. Okay, so let's go back to the slides. I think we are almost at time, so I'm just going to cover everything again. So you can connect to the cloud with the IP, with the app ID or the app name. You get the entire CLI. You can, so here was a previous version of the app where you could actually like start notebooks, or you could actually run an experiment and so on. So for example, here you could have notebooks, but you could also have different things. What extra feature do we provide? So we provide this kind of RESTful API and configurable authentication. So you can get the user object and actually get its username and some metadata about them. So you get this auto-generated RESTful API, which also provide an open API JSON. So you can generate clients in several languages. So you could generate a Python, a TypeScript, or even a Go client for your apps. So you can really orchestrate them from the outside and really make them available to users. We support scheduling, so you can just in your flow set that schedule, and you can say I want to do something every hour. But one thing which is very important here is you can say and anything and really coordinate in the way you care about. You can schedule DAGs, right? So you can just here on the right, on the left, you can write this DAG which does some processing, train and save, and say I want to create this DAG every day and simply run it if it hasn't completed. Distributed storage, so think it as Dropbox, like every machine can just put the data in those drives and simply interact with them with put, get, list, and delete actions. Yeah, so here's more about the drive, and here in the cloud you can see the name of the drive, the component names, and the data which was put inside. So here are a couple of key takeaways. So it's a large and mature library ecosystem and community. Lightning is built for all use cases. It can go from a very simple demo to entire platforms, from data annotation to serving. And you can like do like very tiny things to like very large scale model training and deployment, right? You can also speed up your development with templates. It's runnable locally on Lightning Cloud and on your own BYOC. So BYOC is the Lightning Cloud cluster running on your own cloud account. And it's really like your entire infrastructure written in Python and potentially in React if you want to create your own custom frontends, right? So here are a couple of resources for you to learn more. You can find the documentation on Lightning AI. So you simply go here on docs and you can actually access the docs of the framework and learn how to do more things with the framework. You can also discover like more example of what Lightning apps can be, right? So if you go here, you can see, for example, the flashy apps, the research app we covered, the Scratchpad app, which starts notebooks, the previous version of the Lightning HPO sweeper, the in-video search app, which enable to search through YouTube videos using the clip model, the AI-powered Hacker News app, which provides a way to find content of relevance for your own Hacker News accounts. Yeah, and then if you did like the workshops, please start the project. It's a small action, but it's really a great impact for the framework. So any Q&A? I think we are a bit more time. So if you have any questions, we can cover that. Let me quickly have a look. So yeah, so I think Gustav, like I think right now we got some issues. I tried to resolve all of them before the workshop, but things failed a bit today. So normally it should be back up tomorrow. I will advise you to maybe try again in like in 1 or 2 days when we have resolved all those issues. Could you please share the links here? Yeah, so there is, yeah, so we will send we will share like all those resources, so the slides and all the reports for everyone to actually reproduce all the steps. So it's very simple for people to come around and try things. Okay, I guess we covered everything I wanted to show today. Thanks a lot for attending the talk, and don't hesitate to check things yourself. You can join our Slack. So to join our Slack, you simply go on the Lightning repo, and you should find Slack here. You just click this button, and you can say join our Slack, and that will redirect you to the Lightning Slack, so you can learn more about the project and what people have been building on the framework. Okay, thanks a lot, and see you next time.